DC motor efficiency. Commercially available DC motors are deliberately designed and manufactured to have extremely poor performance. In my opinion, the reason for this is that a properly designed electric motor could easily do away with the need for using internal combustion engines in vehicles, and that would not suit the oil companies or their owners, the New World Order cartels. Worse still, electric motors with coefficient of performance greater than 1 open the way to self-powered free energy systems, and that would never do. The video Peter Lindemann Electric Motor Secrets is available on the web, and I strongly recommend that you watch all of it. It presents the basic facts very nicely. In brief outline, present-day motors act both as a motor and as a generator of electrical power, but they are deliberately wound so that the power generation is used to oppose the input power and so produce a completely crippled output. During World War II, a German engineer rewired a standard electric motor and made it self-powered, that is, it ran and produced mechanical output power without the need for any input power once it had been started. That shows the potential of a properly constructed electric motor with the same size and general structure of any commercial electric motor. Presumably, he did that by adding extra brushes and using some of the windings in generator mode with their output powering the drive windings, which were arranged asymmetrically. There was also one other man who achieved self-powered rewiring of a motor, but neither of those men made their information public knowledge. The con job which has been run on us for many decades now is to wind the motor in such a way that the magnetic fields inside the motor oppose each other. When a current is passed through a coil of wire, it stores energy in that coil, and when the current flow is cut off, that energy needs to flow back out of the coil, and it will do so in the reverse direction. This is sometimes called back EMF, electromotive force, although many people are not happy with that description. However, no matter what you call it, there is energy stored in the coil, and that energy can be used to do useful work. But, the motor manufacturers choose to wind the motor so that instead of extracting that useful power, they use it to oppose a major part of the input power, creating a weak motor which heats up due to the wasted energy. Contributor Ufopolitics points out that a deliberate misdesign of electric motors has, for the last 130 years, been presented to us as the only way to make and operate such motors. He states that because the windings are arranged in a symmetrical way, that a braking effect is produced which reduces the output power of the motor by anything from 50% to 90%. That is, a properly wound motor would have anything from twice to 10 times the output power for the same input power. This misdesign guarantees that present-day motors are always less than 100% efficient and always heat up when run. This misdesign is caused by using symmetrical windings in the motor. Standard motor wiring is quite different, and the killer effect is caused by having two windings which face each other, powered simultaneously with currents flowing in opposite directions. This causes a complete conflict between the magnetic fields, and that destroys the efficiency of the motor. A very experienced experimenter has started a forum thread on the Energetic Forum, both to explain this and to show new and more advanced construction methods and to answer questions and encourage replications and further developments. The forum is at http://www.energeticforum.com/renewable-energy/11885-my-asymmetric-electrodynamic-machines.html and is definitely worth visiting, especially if you are good with mechanical devices. The experimenter uses the forum ID of Ufopolitics, and he has produced an animated video in an attempt to explain the basic problems with present-day DC electric motors. He points out that a problem winding in the standard DC motor looks like this. Effective voltage. Resistance of rotor coil and brushes. Counter electromagnetic field. The input current for any winding is fed in through a single pair of brush contacts. The generated electrical power EC is not extracted and is forced to oppose the input energy EA, leaving only a fraction of the input power to actually run the motor. It is likely that a motor of this type will only operate at 25% of its potential efficiency. Ufopolitics has produced and demonstrated a simple way of overcoming this problem while using the existing motor housing, magnets and brush contacts. He does this by extracting the generated electrical power as a useful output and so preventing that useful power being used against the motor's operation. To implement this, he adds one additional pair of brushes and rewinds the motor coils like this. Symmetry plane. Here, one pair of brushes is at the top and one pair at the bottom of the armature, the bit that rotates inside the motor housing and provides the mechanical power output. The coils are rewound to form a series of separate vertical coils, connecting to one brush terminal at the top and one brush terminal at the bottom as shown above. The input power is between the terminals on the left and flows through the coil shown in brown. The current flow generates a magnetic field, causing rotation because of the permanent magnets marked N, for a magnet which has its north pole facing the coils, and S, for a magnet which has its south pole facing the coils. The black zigzag line represents the resistance to current flow of the wire and brush contacts. The coil shown in green on the right represents that same coil at a later moment when it has been disconnected from the power supply and rotated until it reaches that position, at which point, the energy stored in it is taken off as a useful output via the right-hand pair of brushes. However, this is just an explanatory diagram and it does not show the very important fact that the discharging coil must not directly face a driving coil, because if it does, then the energy discharge would create a magnetic field which would interfere with the magnetic field of the driving coil and create a major problem. Right, to say that again, any one coil is powered on the left-hand side to drive the armature around and provide the output shaft with turning power, torque. Then that rotation disconnects that coil from the input power, leaving the coil charged with energy which has nowhere to go. That charged coil continues round until it hits the second set of brushes, which allow it to discharge through a load and do useful work. The really clever part of the adaptation of the motor is best seen from above the vertical rotor. If, for example, you were to take a 5-pole DC motor apart and remove the windings, the shaft and armature body might look like this. When making an asymmetrical wound rotor, the windings go like this. The start of the wire is secured at the top and then fed downwards through the opening A and back up through the opening B. For the small Radio Shack motor, this winding would be 25 turns of number 30 AWG wire, described as Radio Shack red wire, with a copper wire diameter of 0.255 mm. If you are rewinding a motor armature, please understand that each wire turn needs to be pulled tight in order to make a tight, solid and robust coil which will not vibrate unduly when the armature is spinning. The end of the wire marked finish is not cut, but is taken down through opening A and this time, up through opening C. For clarity, these continuing turns are shown in a different color, but please realize that it is the same single strand of wire being used throughout. The final wire turn goes down through opening A and finishes at the other end of the body of the armature. In these views, the wire runs down into the paper, each turn forming a cylinder. This view may give you a better visual picture of what the coils are wound on. The next step is to connect the start and finish wire ends of this V-shaped double coil to the commutator slip rings which allow current to be passed through the coil at just the right moment. Seen again from one end of the armature, the connections are like this. The commutator slip rings are connected further up on the drive shaft and the start of the winding wire, shown previously in dark green, is connected to the top commutator sector in the position shown here. The finishing end of the wire is connected to the corresponding commutator sector at the far end of the shaft, that is, the sector directly in line with the upper sector just connected to the start of the wire. This completes the first of 5 identical V-shaped coils. The next coil is wound in the same way. The armature is rotated one sector counterclockwise so that sector D replaces A at the top, and the next coil is wound with the wire starting at the top and going down through opening D and up through opening E, repeating the same number of turns, and then, without cutting the wire, the next set of wires are wound going down through opening D and back up through opening F. The start of the wire is then connected to the commutator sector which spans between openings A and E, and the end connected to the corresponding commutator sector at the other end of the shaft. For each of the remaining 3 windings, the shaft is rotated one position counterclockwise and the same winding and connecting procedure carried out. When completed, no matter which opening is placed at the top of the view along the shaft, the windings and commutator sector for the wire connections will be identical. 3-pole motors. The winding arrangement is slightly different for motors which have 3 poles, or multiples of 3 poles such as 6, 9, 12, etc. poles. For the very simple 3-pole motors, the armature looks like this. And with this style of armature, the winds are around the 3 arms, like this. And as before, the commutator sectors at the top are duplicated at the bottom, allowing separate input and output circuits for each of the 3 coils. The windings have many turns, filling the available space, and each winding is connected to the slip ring sector directly opposite it, like this. The start of each winding is connected to the commutator slip ring sector at the top of the armature, and the finish is connected to the slip ring sector directly below it, that is, the sector which is at the same angle as the top one where the start of the wire is connected. This allows the brushes which press against the slip ring sectors to connect to both ends of each coil in turn as the armature rotates. 3-pole motors are particularly powerful, and motors with 6 poles can be rewound with pairs of adjacent sectors amalgamated to give 3 larger sectors. 9-pole motors can have 3 adjacent sectors wound as a single coil to provide the same effect as a 3-pole motor, and 12-pole motors can have 4 adjacent sectors wound as a single coil. The positioning of the brushes is important. With the 3-pole and 5-pole arrangements, the brushes are aligned with the gaps between the magnets which surround the armature. However, the rewound motor can be tuned for improved torque and reduced drive current by adapting the motor housing to allow some adjustment of the position of the brush and commutator slip rings relative to the coils. This adjustment need only be slight, as the angular movement of the brushes will be small. It is, of course, essential that the upper and lower adjusted positions move by exactly the same angular amount so that every upper commutator slip ring sector remains exactly above its corresponding lower slip ring sector. In other words, the commutator slip ring sector at the top and bottom of each coil must be exactly aligned vertically so that the electrical connections are made and broken at exactly the same instant. The commutator and brush arrangement are shown here in Ufopolitics diagrams. This is the simplest of the asymmetrical windings. All coils wound in the same direction, but must all be connected to the exactly opposite commutator element as stated in colors and arrows with the wire's color codes to input. This motor is either all north rotor or all south rotor poles. However, notice it delivers to G out dual coils charge, while charging one coil at input. This motor is very powerful, and delivers excellent outputs. Same config as all starting wires attached to one commutator, and all ends of coils attached to other commutator. The commutator brush marked G, for generator, takes away the energy stored in each coil and passes it to an electrical load. The commutator brush marked M, for motor, feeds energy into the coil from the battery which is driving the motor. The red and blue stripes surrounding the armature are 2 permanent magnets. The magnet shown in red has its south pole facing the armature, and the magnet shown in blue has its north pole facing the armature. This creates a magnetic field flowing horizontally across the armature. The 5-pole arrangement is like this. P1 is pairs of coils start winding number 1. Blue-red means north-south outwards, toward stator. All pairs of coils wound in same direction of windings, just like winding one coil. All coils must start from same commutator and all end at the other side commutator. Commutator's elements must be perfectly aligned upper and lower. Wire AWG30. Red RS wire. M brush motor input. G brush generating side output. Here, the designation R/S stands for Radio Shack, which is a chain of stores in America. In the forum, that is sometimes changed to Rs and should not be confused with the large electronics outlet Radio Spares whose trademark is Rs. Ufopolitics has suggested that the cheap 5-pole DC motor available from Radio Shack should be used by experimenters to become familiar with rewinding DC motor coils. Being a cheap product, those motors do not have a particularly high build quality, but they are suitable motors for experiments. Forum members share the details of how they dealt with adapting these and other motors. I have to admit that motor windings and operation tend to confuse me, and I sometimes find it difficult to understand what Ufopolitics means when he talks about different winding strategies. However, it seems reasonably clear at this early stage of forum development, that his objective is to produce two things. 1. A very powerful electric motor which can be used in serious forms of road transport as well as for other practical applications, and 2. A powerful motor-generator combination which can produce useful generated electrical power. While Ufopolitics is very patiently going through many of the possible variations on how a DC motor can be wound and connected, and showing various forum members where they have failed to get some of their windings positioned correctly, he has also shown some of the best ways of connecting a rewound motor used as a driver or prime mover as some people like to call it, and a rewound motor which is to be used as an electrical generator. He shows two important ways for making a very effective motor-generator combination, as shown here. Asymmetric motor body 256. It needs to be realized that these arrangements are not conventional arrangements and that the rewound motors operate in a different way to motors bought off the shelf. For this reason, it is necessary to isolate the electrical output to prevent current flowing through the load from affecting the operation of the motor-generator combination. This can be done by placing a diode in each of the output lines and charging a capacitor bank which is then used to feed whatever load is to powered. If my understanding is correct, then feeding any cold electricity produced into a capacitor causes the current to become conventional hot electricity. It is not clear if that action is part of this arrangement, although the circuitry shown should be used. This is the second version. Ufopolitics comments on these arrangements as follows: as we excite the input of the motor, the generator will start producing energy, and that additional energy will flow through the motor output side because they are connected in series here. Two rectifiers must be connected at both output terminals, positive and negative, to avoid backflow from closing the circuit through the load. As the motor accelerates, the generator boosts the energy flow which then runs through the motor, augmenting the output fields, and when the output is loaded, then an engagement of both machines occurs as they start to compensate each other through their output flows. It should be understood that the output should be capacitor banked in a dedicated reservoir. When designing a generator for a specific, existing asymmetric motor machine, it must be understood that generator interactions should be considered to run as counter-rotation to the motor machine's originally conceived rotation, which is easily done by just moving brush lines passing stator bisector angles to the opposite of those needed for a motor, or alternatively, setting the timing backwards. This will definitively enhance the assisted rotation of both machines when connected together in this face-to-face mode. As I do not find the forum comments easy to understand, I recommend that you visit the forum and read the posts, as you may well understand the conversations easier to follow than I do. On the forum, Sanskara316 states, I have rewound a small 3-volt 3-pole motor. I used an almost dead, 6-volt sealed lead acid battery to power the motor. This battery just sits at around 4 volts, and if given a load, even a small lead, its voltage drops to 1 volt. The rewound motor started very slowly, barely spinning, then after a minute or two it started to spin faster, and I noticed that the voltage on the battery was slowly climbing. I connected a small LED flashlight to the generating side and it lit up. Now the battery voltage under load is around 2+ volts. It's been running for an hour now and the machine squeals a lot. It is conditioning the battery and the meter cannot be showing what really is happening. The motor draws 300 milliamps. That's not possible as the battery just doesn't have that power. To which Ufopolitics remarks, well, I am glad you have witnessed some of the effects. These rewound motors do recondition batteries. Remember, radiant energy is taking over the machine, so radiant energy comes out through the input also, which is the reason why we get high volts amps reading on a meter. These motors use very small amounts of current and volts. Inside the motor, every coil is being self-electromagnetically pulsed because they auto-disconnect from the power source. then the next coil in the sequence is assisted by the first coil when it has rotated to its next position, and so on. The commutator switching has become a self-oscillator for every independently energized coil. Another forum member Process Hero says, I have also replicated the battery charging events that Sanskara 316 indicated. I started with a 12-volt 4-amp-hour battery which I had been using with another circuit 2 weeks ago and had not recharged it after using it for hours. It was sitting at 12.40 volts. I took my best running rewound motor, plugged it in direct and ran it. The battery voltage dropped to 12.24 volts and stayed at that level for 30 seconds. The battery voltage then started to rise 0.01 of a volt per minute. When it was at 12.27 volts, I disconnected the motor. The total runtime was less than 5 minutes. I then let it rest for 5 minutes. At the end of the 5 minutes, the battery voltage had risen to 12.43 volts and is still at that voltage now. Just think what a larger motor would do on a big battery bank. Everybody needs to document this test as it proves what Ufopolitics said. New DC motors, and particularly cheap motors, will have brushes which do not mate cleanly with the commutator slip ring sectors, and so, when the modification has been made, running the motor for some time allows the brushes to wear in, and that raises the efficiency of the electrical connections, which in turn improves the performance of the motor. If you wish to build and test one of these motors, then you can find help and support in the forum with your questions answered and numerous videos and photographs from different experimenters to help you.